Today we are going to be looking at equations. We will look at linear equations. First and foremost, an equation involving two variables, x and y. For example, ax plus by equal to c is said to be a linear equation. It means therefore that if you draw the graph of this, you will have a straight line. Now, to find x and y algebraically, we require two equations which are solved simultaneously. You will recall the word simultaneous equations. Number two, we will also look at quadratic equation. A quadratic equation is of the form ax squared plus bx plus c equal to 0. Where a is not equal to 0, because if a is equal to 0, it becomes a linear equation. A, b, c are constants. Quadratic equations have a method of solution. How do we solve quadratic equations? We can solve quadratic equation by factorization. We can also solve quadratic equation by completing the square method. And then, of course, we can also use the formula, which we normally refer to as the general formula for solving a quadratic equation. Now, the solutions are also called roots of the equation. So when you solve a quadratic equation, you have the answers. The answers are also called the roots of the equation. Usually, we have two distinct roots. We will recall that in a quadratic equation or a quadratic graph, you will have, this is your y-axis and this is your x-axis, and the curve can come in this form. Then you have two distinct points, and these are the points we call the roots. Maybe the value of, this is your p and this is your q. They form the roots of the quadratic equation. The curve can also go in another form, and it goes like this, and then you have a point here, you have a point here. At the point where it's crossing the x-axis, those are the ones we refer to as the roots. In whichever case, the curve can either be like this, or it can be like this. But there is a third case, equal roots, which indicates that the curve touches the x-axis at only one point. What we mean by this is that here is your x-axis, and here is your y-axis, and then the curve is coming and it touches it only at one point here. Maybe this is from P. So in this regard, you say you have an equal root. Then we talk about cubic equations, and they are dealt with as polynomial functions. Linear equations, quadratic equations are all polynomial, but specifically, cubic equations will be dealt with like polynomial functions. The solutions or roots are three distinct values of the variable. What usually happens is, for the cubic equation, your graph will look like this. This is your x-axis, this is your y-axis. And so the graph can come in this way and go like that. And then you now have distinct points here which form the solution, and this can be a point A, point B, and point C. So the A, B, and C form the roots of the quadratic, of the cubic equation. So that is why your answer will have three distinct values of the variable, maybe x. So we can answer x is equal to maybe this one x minus A, and then this one is a B, and then this one is a C. So this gives you the solution of that quadratic function or equation. We now take the first example, and that is solve for x and y respectively in the simultaneous equations minus 2x minus 5y equal to 3, x plus 3y equal to 0. Solution. You will recall that in solving the simultaneous equations, linear simultaneous equations, you can solve this by elimination method. By elimination. You can also solve this by substitution. Although we can also solve this by graph, but we're looking at the algebraic solutions. So with this method, from the knowledge of matrices, you can still solve this one by Cramer's rule. By Cramer's rule, from the knowledge of determinants and matrices. So from determinants. Okay. Now, but for this case, we are going to use either by elimination or by substitution, whichever one is applicable. So we write our first equation, which is minus 2s minus 5y equal to 3. You call this one your equation 1. You now take your s plus 3y, you call this one your equation 2. Usually when the coefficient of any of the variable is 1, then you can make that the subject of the formula. So from 2, our s is equal to minus 3y. You can call this a derived equation from equation 2 and call it equation 3. Now what do? You can now substitute for s in equation 1. So let's see how that is done. We substitute for s. So we have minus 2, our s now is minus 3y, and this is minus 5y, everything is equal to 3. So we have eliminated, in a way, our s. So multiply out, this will give you 6y minus 5y equal to 3, and therefore y is equal to 3. So you have gotten the first root, the first value, which is y equal to 3. What do you do again? Substitute for y in the derived equation you had, which is s equal to that. So our s will be equal to minus 3 times y, and our y is 3, and the result is minus 9. Therefore, the conclusion, you can have your s is minus 9, and your y is 3. Please do not write the value of y before s in a situation like this when they are put it in a coordinate form. Always write the value of s followed by the value of y. We have now used a method of elimination to solve this. We can still use the method of substitution, and I'm going to also use that method for you to see how that method can also be effectively used. Now, the example 1 which we solved earlier, we used the method of substitution to solve it. We made s the subject of the formula in the second equation, and then we substituted in the first equation, and then we got the value for y, substituted again, and we got the value for s. Then we wrote down our answer. But this time around, we want to use the method of elimination. Let's say by elimination. By elimination. To eliminate means to remove. So we have our minus 2s minus 5y equal to 3 is still your equation 1. Our s plus 3y is equal to 0 is still your equation 2. Now, because we want to eliminate, we have to make the variable of one of the equations equal in terms of modulus to the variable in the other one. In this case, if you now take equation 2 and you multiply it by 2, you will now have 2s plus 6y equal to 0. Call it equation 3. Now bring in your equation 1, which is minus 2s minus 5y equal to 3. This is your equation 1. You realize here that the coefficient of s here is 2, and the coefficient of s here is 2 as well. But here it is minus 2. So, and to eliminate this, you carry out addition. So we say equation 3 plus equation 1 When you add this, it will be 0. Then you now have 6y minus 5y equal to 0, also plus 3. Now this eventually will give you y, and it's equal to 3. So what next are you going to do? You can therefore say substitute for y in equation 2. So we have s plus 3y, our y now is 3, is equal to 0. So that your s plus 9 is equal to 0. Therefore s is equal to minus 9. So writing your answer, s comma y will be equal to your minus 9 and followed by 3. Or some will write it as s equal to minus 9, y equal to 3. You can combine it in this form, or you write it separately in that form. Example 2. Solve for s and y if s minus y is equal to 2 and s squared minus y squared is equal to 8. Our solution. We are going to solve these problems in 2 modes. Let's take the first mode. You have s minus y equal to 2. Call this equation 1. You now also have s squared minus y squared is equal to 8. This is equation 2. You will observe that in equation 2, s squared minus y squared is a difference of 2 squares. Therefore, equation 2 is equal to, equation 2 becomes s minus y into s plus y equal to 8. Equation 2 now has become this. Alright. Now, you observe again that s minus y is 2 in equation 1. So from 1, our s minus y is equal to 2. Therefore, we have 2 into s plus y equal to 8. And that means s plus y is equal to 4. Call this equation 3. So, now that you have gotten equation 3, we now combine equation 3 with equation 1 to bring your s minus y equal to 2. This is your equation 1. Take note of that. So equation 3 here is derived using the fact that s minus y is equal to 2 in equation 1. And also using the fact that in equation 2 is factorizable, the left hand side is factorizable, and getting a factor that is in the first equation. So in other words, all we do here is to add. The reason is because y minus y is equal to 0. So s plus s is 2s, and 4 plus 2 is 6. Therefore your s is equal to 3, dividing both sides by 2. Now that you have gotten the value of s to be equal to 3, you can then now say substitute for s in any of the equations. So let's put it in equation 1. So we have there s, which is 3, minus y is equal to 2. Now, collect like terms, we have 3 minus 2 is equal to y. I move this to this side and I brought this to this way. So that we now have this. Therefore, your y is equal to 1. So, in conclusion, sy in this case is equal to, your s is 3 and your y is 1. The same example, question number 2, we have to solve for s and y if s minus y equal to 2 and s squared minus y squared equal to 8. We are going to use the second method. Let's call it method 2. Now the process is s minus y is equal to 2, call that equation 1, and then s squared minus y squared is equal to 8, we call that equation 2. Now from equation 1, you can make s the subject of the formula. S is equal to y plus 2. Call this equation 3. What do you do next? You now substitute for s in equation 2. And then what do you have? Our s now becomes y plus 2 all squared minus y squared. Everything is equal to 8. You will now expand this to give you y squared plus 4y and then plus 4 minus y squared is equal to 8. You now discover that y squared minus y squared will go. You are now left with 4y equal to 8 minus 4, and that is 4. Therefore, your y is equal to 4 all over 4, and the value is 1. So what do? You now substitute for y in equation 3. And in equation 3, you have s equal to y plus 2, which is 1 plus 2. And the result is equal to 3. So the final analysis, your s comma y is equal to 3 comma 1. The solution is the same. Example number 3. A polynomial in s whose roots are 4 over 3 and minus 3 over 5 is dash. Now here is a situation where you are giving the roots of a polynomial, and you have to derive the equation of the polynomial or the polynomial itself. Now our solution, please pay attention to this, is quite simple, because when you normally find the roots, you will say s is equal to this or s is equal to that. So let's see, s is equal to 4 over 3, and then our s is equal to minus 3 all over 5. Beautiful. Now, I want to take everything to the left hand side, which means s minus 4 all over 3 is equal to 0. Put this in bracket, and then we have s plus 3 all over 5 is also equal to 0. Now, in solving a quadratic equation, you will now multiply the factors. So s minus 4 over 3 times s plus 3 over 5 will now be equal to 0. What next? Open the bracket, that becomes s squared, and that is plus 3s over 5 minus 4 over 3s, and then we have minus 4 over 3 times 3 over 5 will give you 4 all over 5. Everything here is equal to 0. Now let's eliminate the fraction to make it easier. We multiply all through by 15. So we now have 15s squared plus 5 into 15 is 3, that will give you 9s. And here 3 into 15 is 5, that will give you minus 20s. And 5 into 15 is 3, 3 times that is minus 12, and of course equal to 0. We can now collect like terms, so we now have 15s squared, and then we have minus 11s, and then we have minus 12, everything equal to 0. This is the required polynomial. I want us to also know that this problem can also be solved using what we call the sum of roots. Using the sum of roots and the product of roots. How do we use that? Let's say using sum and product of roots. Our sum of roots usually is alpha plus beta, where alpha and beta are said to be the roots of a quadratic equation. So the sum of the roots here will give you your 4 all over 3 plus minus that will remain as 3 minus 3 all over 5. And of course this will give you, the LCM here is 15. So we now have 20 minus 5 into 15 is 3, and that is minus 9, and everything here all over 15. The result of this one will be equal to 11 all over 15. Then you now talk about the product of root, which we write as alpha times beta, product. And what does that mean? This means that we have your 4 all over 3 multiplying minus 3 all over 5. 3 will cancel, and then what we have left is minus 4 all over 5. We are now going to write the equation. The equation is using s squared minus alpha plus beta times s plus alpha times beta equal to 0. This is the sum and this is the product. Okay, with this one, we now write s squared minus, our sum was 11 over 15. 11 all over 15 of s, and then our product was minus, so it is minus 4 all over 5. Everything is equal to 0. Clear the fractions, it becomes 15s squared minus 11s, and when you multiply this by 15, you have minus 12, and the result is also equal to 0. This is a polynomial using the sum and the product of roots. Here is another question, example 4, and here we have a graphical representation of a quadratic equation or function. This graph is a parabola representing a quadratic function. Now, we have to write the equation of this graph. So the graph above is represented by dash. What equation represents this graph? Please, this is quite easy. Our solution, watch it carefully. You observe that the graph is cutting the s-axis at two distinct points. So we say s is equal to minus 2, and then it's also cutting it at s is equal to 1 over 4. These are the two distinct points. And then take note here again that the graph is also cutting the y-axis at the point 2. We will take care of that after we have written down the equation. So let's see what happens here. From the knowledge of the previous example we solved, we can have s plus 2 is equal to 0, and then we also have s minus 1 over 4 is equal to 0. Some people can decide to do, well, let's leave it the way it is. Some can say it is 4s minus 1 and it's equal to 0. If you use this or you use this, the result will remain the same, no problem at all. So let's use this just for the change. So we now have s plus 2 multiplying 4s minus 1, everything is now equal to 0. This is a little bit more beautiful because we have already done away with the fraction. So here we go, s times 4s will give us 4s squared, and then we have minus s, and then we have plus 8s, and then we have minus 2 equal to 0. Simplifying further, eventually we have 4s squared, and then plus 7s, and that's minus 2 equal to 0. Therefore, we say y is equal to 4s squared plus 7s minus 2. Now, hold on. You realize that if we agree that this is the solution, then an error has occurred. The error, therefore, is occurring here. This minus 2 is a point where the curve is cutting the y-axis. But over there in the graph, the value is a positive value. So we need to change this minus into a positive value. And how do we change that to a positive value? Allow me to remove this again. And then we must remove this positive value, negative value by multiplying all the 10 by a negative value. Say minus 1. So minus times this will give you minus 4s squared. Minus times this will give you minus 7s. Minus times this will give you plus 2. And minus times 0 will remain at 0. So therefore, you can write this, therefore, your y is equal to, you can start with the constant 2 minus 7s minus 4s squared. Or you can leave it even the way it is by writing your y equal to that. But this is preferable. So you now see that our y is equal to 2 minus 7s minus 4s squared is the equation representing the graph that was given to you earlier. Take note of the minus sign transformation, very important. In every objective question that will come your way, for a question like this, you always see this 1 as one of the answers. The one of 4s squared plus 7s minus 2 equal to 0. And students, being what they are sometimes, you will rush to assume that this is the correct solution because you are always in a hurry. Take your time to observe the principles before you put out the final solution. That's an example 5. Look at the graph we have here. This is actually a cubic graph. This is a cubic graph. Now, the graph above is represented by that, similar to the one we did, which was a parabola. Observe in our solution, what do you have to observe? Observe the point where the curve is cutting the s-axis. And what are those points there? Our s is equal to minus 2, our s is equal to minus 1, and our s is equal to 1. This is all you need to know. The next thing, you carry out the transformation like what we're doing. Our s plus 2 will now be equal to 0. Our s plus 1 will now be equal to 0. And then our s minus 1 will also be equal to 0. So what do you do next? You now multiply s plus 2 into s plus 1 into s minus 1. Everything is equal to 0. Beautiful. And so what next? You multiply everything out. Let's start. Let's take the first one. So we have s squared plus s plus 2s will give us plus 3s. And then 2 times 1 is 2. We are finished with that. Then also bring in your s minus 1. Everything is equal to 0. So we pick this now to multiply everything there. So we have s times that is s cubed. S times that is minus s squared. We pick this now. 3s times s will be plus 3s squared. This will multiply that to give you minus 3s. Then you pick the last one. Plus 2 times that will give you plus 2s. And then 2 times minus 1 is minus 2. Everything is equal to 0. Beautiful. So what next? You cannot collect like terms. In this case, we have s cubed is standing on its own. There is no common term with that. Then take a look at this. This is squared and this is squared. So minus s squared plus 3s squared will give you plus 2s squared. And then what next? Look at your s. Minus 3s plus 2s will give you minus s. And then you have minus 2 is a constant on its own. And so therefore you now write y equal to s cubed plus 2s squared minus s minus 2 is the equation represented by the graph above. Number 6. Here is a diagram for us, a graph representing a cubic function and a linear function. I specifically bring this to us to solve because we have already dealt with inequality. So given this type of graph, we are asked now to find, say the shaded portion in the graph above is represented by that. What are the equations or inequalities representing the shaded region? We want to write the inequalities representing the shaded region. Look at the straight line. It is making an angle of 45 degrees with the s-axis. So here we go. We will now write, first and foremost, the equation of the straight line. So solution. To write the equation of the straight line, remember we have y equal to ms plus c. Our c is a point where it is cutting the y-axis, and of course in this case it is 0. So our y is equal to ms plus 0. Then our n is the gradient. And the gradient here is also equivalent to what we call the tangent of the angle times 45 degrees. Gradient is tangent. So we have y equal to, times 45 is 1 times s. Therefore we have y equal to s. Or you can say y minus s is equal to 0. This is your first equation. Now we take the equation of the curve. You observe here that the curve is cutting the s-axis at s equal to minus 1, at s equal to 0, and at s equal to 1. Recall what we did earlier. This becomes s plus 1 equal to 0, and this is s equal to 0, and this is s minus 1 equal to 0. Multiplying all together, s plus 1 times s times s minus 1 is equal to 0. This will give you s squared plus s multiplying s minus 1 equal to 0, and that will give us s cubed minus s squared plus s squared, and then we have minus s is equal to 0. In this regard, we have s cubed minus s is equal to 0. Now, we are interested in looking at the region where the solution lies, the shaded region. So therefore, the inequality representing the shaded region, for the line, it means that we have y minus s. Below the line is shaded, so the region where the solution lies is less than or equal to 0. And then for the curve, you realize that our s cubed, so y equal to s cubed minus s is the equation, which means that our y minus s cubed minus s is equal to 0. Take note of this. And so, we can therefore write that our y minus s cubed minus s above the curve here, you can see it is shaded, is greater than or equal to 0. There's a correction here, please. Now we have y minus s cubed plus s, and then this is also plus s greater than 0. In conclusion, our y plus s minus s cubed is greater than or equal to 0, and then our y minus s is less than or equal to 0. This is the inequality representing the region that is shaded in that graph. We look at question number 7. A graph again, a cubic graph is given to you. And this graph is cutting the s-axis at minus 1, at 1 and 2. Use the graph of the curve y equal to f of s above to solve the inequality f of s is greater than or equal to 0. Please look at this one, our solution. This is technical. Our solution will be of this form. So look at it. Take a look at your graph. At what point is the graph above 0? It's above 0 at this shaded point. The graph is above 0 here. The graph is also above 0 in this other part. So you actually have the solution as between minus 1 and 1 and above 2. So our solution, from what we have already described, will now be written as the solution says f of s is greater than or equal to 0. Therefore, the solution is minus 1 is less than or equal to s, and then less than or equal to 1, comma, and then our s is greater than or equal to 2. And that is the solution to the problem. Let me remind us, please, these are areas that a must. Most of these problems we are solving, they are almost a must in most examinations, especially the matriculation examinations. Expect to see them in one form or the other. Take note of them. They are quite important and they are interesting. Once you have understood this, each time you are given such problem, it's a walkover. Question number 8. Find the values of s where the curve y equal to s cubed plus 2s squared minus 5s minus 6 crosses the s-axis. Solution: your s cubed plus 2s squared minus 5s minus 6 crosses the s-axis at the point where it's equal to 0. Where y is equal to 0. At the point where y is equal to 0, the curve will be crossing the s-axis. Now, how do I get the values of s? Recall that when we were dealing with polynomials, you have here a minus 6. And there are factors of minus 6. We can start trying. We can try maybe s is equal to 2. We can try maybe s is equal to minus 1. We can also try s is equal to minus 3. Say for example, so if we take the first case, we now have that our f of s is equal to this. So you now take your f of 2 will be equal to 2 raised to the power 3 plus 2 into 2 raised to the power 2 minus 5 times 2 minus 6. When you simplify this, your result is equal to 8 and then plus 8 minus 10 minus 6, and the answer is equal to 0. Therefore, your s equal to 2 is a solution. You do the same thing with f of minus 1. You will have minus 1 cubed plus 2 into minus 1 squared minus 5 into minus 1 and minus 6. The result of this is equal to minus 1, and then this is plus 2, and this is plus 5, and this is minus 6. Answer is equal to 0. Therefore, s equal to minus 1 is a solution. You do the same thing with f minus 3, and this will be equal to your minus 3 all cubed, and then of course we have plus 2 into minus 3 all squared minus 5 into minus 3 and minus 6. The value will be equal to 0. So when you simplify that, it will give you 0. Therefore, our solution s is equal to minus 3 and then minus 1 and then equal to 2. You will observe that all the ones I have tried, they gave us the value equal to 0. It's not accidental, it is intentional. But it means that you can try any other number, you discover that it will not give you 0. Obviously, the value of s at that point is not a solution to the given equation. So we have done this, and then this is correct. In other cases, you can just find only one factor, only one of the solutions. And then you go through the process of dividing the factor into the given polynomial. And then you will now get a quadratic function, and then you factorize, and you will also arrive at the same solution. Question number 9. Solve the pair of equations for s and y respectively. 2 into s to the power minus 1 minus 3 into y to the power minus 1 equal to 4. 4 into s to the power minus 1 plus y to the power minus 1 is equal to 1. Our solution. There are two ways of solving this problem. Let me take the one of using the indices. By the laws of indices, we can write the first one as 2 all over s minus 3 all over y is equal to 4. So that we now have 2 into 1 over s minus 3 into 1 over y, and this is equal to 4. You can decide to call this one equation 1. Then the second one, you will have your 4 all over s plus 1 all over y is equal to 1. This means that 4 into 1 all over s plus 1 all over y, and this is equal to 1. Call this equation 2. Now, elimination method. You can multiply equation 2 by 3. So equation 2 times 3. So this will give me 12 into 1 over s plus 3 into 1 over y is equal to 3. Call this equation 3. And bring in your equation 1, where you have 2 into 1 over s minus 3 into 1 over y, and this is equal to 4. Now what are you going to do with these two equations? These two equations, you will now add them, because plus 3 minus 3 will be 0. So if you add this to this, you have 14 into 1 over s is equal to 3 plus 4, and that is 7. So that your 1 all over s will be 7 all over 14, which is equal to half. Therefore, what is the value of s? You cross multiply, s times 1 is s, and 2 times 1 is 2. Therefore, your s is equal to 2. We now substitute for s in equation 2. And in equation 2 you have 4 into 1 all over s, and then we also have plus 1 all over y is equal to 1. So if you multiply this, you have 2 plus 1 over y is equal to 1. Therefore 1 over y is equal to 1 minus 2, which is equal to 1. So what would be the value of y? Y in this case is therefore your y is equal to minus 1. Your y is equal to minus 1. So the final solution, s is equal to 2 and your y is equal to minus 1. Question number 10. 7 years ago, the age of the father was 3 times that of the son. But in 6 years' time, the age of the son will be half that of the father. If s represents the age of the father and y the age of the son, what is the present ages in terms of s and y? Solution. You have been told that the father's age presently is s. Then 7 years ago, the father was s minus 7 years old. And then 7 years time, the father will be s plus 6 years old. Okay. Now let's look at the son. Presently is y years. And then you are told again in this case that 7 years ago, the son will be y minus 7 years old. And then of course 6 years time, the son will be equal to y plus 6 years old. Alright. Now this is what we have. We are going to combine them based on the instruction given to us. We are told that 7 years ago, the age of the father was 3 times that of the son. So this is the age of the father, and it was equal to 3 times the age of the son as at that time. So this is equal to, so let's get them out quickly. The instruction says that 7 years ago, this is the father's age, and the age was equal to 3 times the age of the son. And so this was the age of the father 7 years ago. This is the age of the son 7 years ago, but they are equal because the age of the father is 3 times the age of the son as at that time. Working this out, we have s minus 7 is equal to 3y minus 21. And we can bring this as s minus 3y is equal to minus 21 plus 7, giving you s minus 3y is equal to minus 14. On the other hand, we are told that in 6 years time, the father's age is s plus 6. Or rather, the son's age, let's look at the son. The son was y plus 6 years. And then this age was equal to half of the age of the father. And the age of the father then, at that time, is s plus 6. So in this regard, we have 2y plus 12 equal to s plus 6. I have crossed and multiplied by 2, or I multiply both sides by 2. Then in this case, I have my 2y minus s is equal to 6 minus 12, giving me 2y minus s equal to minus 12. Okay, so with this, we are ready now to write down the final solution. So therefore, for the first case, we can have this as 3y minus s is equal to 14. I multiply through that equation by minus. Then we also have 2y minus s is equal to minus 12. We can have it this way, and the results are correct. But because I want to make this side to be positive, I can rewrite this one. Instead of writing minus 12 there, I will now rewrite this one as our s minus 2y equal to plus 12. They are just various forms of writing the same solution.
you should be conversant with them, just manipulating the minus and plus sign, movement from the right to the left, from the left to the right. Whichever way, you should be conversant with the movement. So that no matter the option that the examiner will give to you, you should be able to pick it out and get your. Now we have question number 11, and here is another graph given to you. But this graph is cutting the y-axis at this point and touching the x-axis at one distinct point. Just one definite point. Just one point, not distinct. One definite point here. Alright, and you are asked to write the equation of this line. As we said earlier, this is a case where you have equal roots. So our solution, say for equal roots, another equation for equal roots. Here s is equal to 2 and s is equal to 2. That is what we mean. And so it means that s minus 2 and is equal to 0 and s minus 2 is equal to 0. And remember what to do, s minus 2 times s minus 2 is equal to 0. And this becomes s squared minus 4s and plus 4 is equal to 0. So an equation f of s will be equal to s squared minus 4s plus 4. Or y equal to s squared minus 4s and then plus 4. Whichever one is an acceptable solution. We shall now take a look at a situation where the roots of a quadratic equation is represented generally by an alpha and a beta. If alpha and a beta represent the roots of a quadratic equation, we can derive the equation itself. Now, if alpha and beta are the roots of a quadratic equation in S, then it means that S squared minus alpha plus beta S plus alpha beta is equal to 0. This knowledge is from the symmetric functions we discussed under quadratic equation. You can see related videos on that. But meanwhile, for this purpose, we compare with the standard form of a quadratic equation. Comparing this and this, before we can make the comparison, realize that the coefficient of s squared here is 1. So we must first of all make the coefficient of s squared in the standard form to be equal to 1. And how do we do that? We divide all through by the coefficient of s squared. And so when we do that, which is 8, we do that, we will now have this expression here, or this equation. Now with this equation, we cannot compare this one with the former equation. In this case, the comparison is the coefficient of s squared is 1, coefficient of s squared here is 1, so no problem. But the coefficient of s is b over a here, and the coefficient of s is minus alpha plus b. So if we take only alpha plus b, then this one becomes minus beta, minus b all over a. We have multiplied both sides by minus to remove the minus of this alpha plus beta to get your minus b all over a. Then the alpha times beta is compared to c all over a. This is what we call the sum of roots, and this is what we call the product of roots. Note also that if you are given alpha squared and beta squared as the roots of a quadratic equation, the only way you can solve this is to express this thing as a sum and as a product. And to express this as a sum and as a product, you have alpha plus beta squared minus 2 alpha beta. If you expand this and subtract this, you get back the original term on the left hand side. Similarly, alpha over beta plus beta over alpha will give you alpha plus beta squared minus 2 alpha beta all over alpha beta. If you expand this, you subtract this, and you carry out the division, you will get back the original value, which is on the left hand side. We shall now quickly take a look at example number 12. That's question 12 in the series of examples on this topic equation. If alpha and beta are the roots of the equation, 3s squared plus 5s minus 2 equal to 0, find the value of 1 over alpha
plus 1 over beta. Our solution. First and foremost, we take our 1 over alpha plus 1 over beta is simplified as alpha beta. This is now beta. This is now beta, and then plus alpha. The result of this is alpha plus beta all over alpha and beta. So how do we get alpha plus beta and alpha and beta? From the equation, from 3s squared plus 5s and then minus 2 equal to 0, we can divide all through by 3, so this becomes s squared plus 5 all over 3s minus 2 all over 3, and this is equal to 0. Recall that your alpha plus beta is equal to minus b all over a, and that is equal to minus 5 all over 3. While your alpha times beta is equal to c over a, and that is equal to minus 2 all over 3. So now that you know this, what do you do? Therefore, s squared minus the sum of root, which is minus 5 all over 3 of s, plus the product of root, which is minus 2 all over 3 equals to 0. So our s squared minus times minus will be plus 5 all over 3s, and then minus 2 all over 3 is equal to 0. Okay, what do? We clear the fraction by multiplying 12 by 3. 3s squared plus 5s minus 2 is equal to 0. So we are trying to find the equation. Therefore, the equation is y equal to 3s squared plus 5s minus 2, and that is. Question number 13. If the roots of half s minus 1 into s plus 1 equal to 0 are alpha and beta, find the value of alpha plus beta. Solution. We have half s minus 1 multiplying s plus 1 equal to 0. The first thing is to open the bracket, so that becomes half s squared plus half s minus s minus 1 equal to 0. Let us clear the fractions by multiplying through by 2. So this becomes s squared plus s minus 2s minus 2 equal to 0. Now we can rearrange the standard form. This is your s squared, and this is minus s, and minus 2 is equal to 0. Of course, we know what our alpha plus beta is minus b all over a. And from this equation here, since the coefficient of s squared is already 1, so the value of b there is minus b, minus 1, in this case minus 1. So this will be equal to minus, there's a minus here, into the minus 1 that is there, all over a, and our a is what? Is 1. So at the end you now have the answer to be equal to 1. So the value you are asked to look for, alpha plus beta, is equal to 1. There's a concept here I want us to have an understanding on before we continue. It's called complete the square problem. We realize that to complete the square problem, we use a formula. We record that formula is b squared equal to 4ac. This is gotten from the discriminant of the formula for solving a quadratic equation. I will not go too deep into that, but let's recall that b squared equals 4ac represents the equation for equal roots. When you have to algebraically find the roots of an equation or for equal roots, you will use b squared equal to 4ac. It also represents the equation for the perfect square, where c is the unknown. We are going to do that quickly so that you catch exactly what we are trying to say here. For example, what must be added to 4s squared plus 5s to make a complete square? When you talk about making a complete square, that is, you can write the expression as a square. So let's see what happens here. What must I add to this one so that I can write it as a square? So our solution, we will now say let k be what will be added to make it a complete square. So I can have my 4s squared plus 5s plus my k. I now want to find my k. I will now use my b squared equal to 4ac. Our b here is your 5. So that means 5 squared equal to 4. Our a is the coefficient of s squared, which is also 4. And our c now is equal to k. Therefore, we discover that k is equal to 25 over 16. Since the question specifically asks us, what must we add to the expression to make it a complete square? This is what you can add to make it a complete square. Here we have 4s squared plus 5s. And we are interested in looking for what will be added to this to make it a complete square. So let's take the 4 out and have s squared plus 5 all over 4s. What I have done here now is factorizing using 4. Now we will look at the coefficient of s in this place, and the coefficient of s is 5 all over 4. You find half of this coefficient, and this will give you 5 all over 8. Now you will square that value, 5 over 8. If it is squared, we give you 25 over 64. Okay, so we now have 4 into s squared plus 5 all over 4s plus 25 all over 64. And then if you open the bracket again, we now have 4s squared plus 5s and then plus 25. And when you divide this, 4 into 64, 1, and that is 16. Therefore, you will add 25 all over 16 to make the expression a perfect square. To make 4s squared plus 5s plus 5s a perfect square. And that was the solution we got, where we used the formula b squared equal to 4ac. We are going to look at another dimension of this problem. Assuming you are told to write out the expression as a square, what should you do? To write out the expression 4s squared plus 5s plus 25 all over 16 as a perfect square, we will do the following. So we have here 4s squared plus 5s plus 25 all over 16. You will recall that we can write this as 4 into s squared plus 5 all over 4 s and then plus, I'm dividing through by 4 now, plus if you now divide this through by 4, you now have 25 all over 64. Now once this is done,
We will now take a look at the coefficient of s in this place, and this is 5 all over 4. We find half of this coefficient, and that will be equal to 5 all over 8. So we will write 4 into s plus 5 all over 8, bracket open and close it, all squared. 4 into s plus 5 all over 8, bracket open and close it, all squared. In other words, we can have this as 2, and then this is your s plus 5 all over 8. Everything here is squared. We will have written it as a perfect square. This 2 squared is a 4. When you multiply this out, at the end of the day, you will have the original value which we needed. Question number 15. What will be the value of k so that the quadratic equation ks squared minus 4s plus 1 equal to 0 has 2 equal roots? 2 equal roots. Which means in this case, their roots are equal. We can apply the formula b squared is equal to 4ac. And then here, if you look at the equation given to you, ks squared minus 4s plus 1 equal to 0, your a here is equal to your k, your b here is equal to minus 4, and your c here is 1. So substituting them in the equation, so we now have b squared, which is minus 4 squared, will be equal to 4 times k and then times c. So the result is 16 here equal to 4k. Therefore, k, which is what you are asked to find, is 16 all over 4, and the answer is equal to 4. So when k is equal to 4, that expression will be a perfect square. Exercise. Question number 1. Take a look at this figure given to you. There's a curve, another curve. The figure above represents the graphs of y equal to s into 2 minus s and y equal to s minus 1 into s minus 3. What are the s coordinates of p, q, and r respectively? Option A, B, C, and D. Question number 2. Solve the equation y minus 11 root y plus 24 equal to 0. The options are A, B, C, and D. Question number 3. Solve the equation s minus 2 into s minus 3 equal to 12. A, B, C, and D. These are the options. Question 4. An n minus 2 square sided figure has n diagonals. Find the number n of diagonal for a 25-sided figure. A 7, B 8, C 9, and D 10. Question number 5. Here's a diagram or a figure or a graph for you. And this, of course, you must recognize is a cubic function. So we have a cubic function f of x is specified by the graph above. The values of the independent variable for which the function vanishes are A, minus 1, 0, 1, B, minus 1 less than or equal to s, s less than or equal to 1, C, s less than minus 1, and D, s less than 1. Question number 6. Find the two values of y which satisfy the simultaneous equations s plus y equal to 5, s squared minus 2y squared equal to 1. We have options A, B, C, and D. Question 7. Solve the equations m squared plus n squared equal to 29 and m plus n equal to 7. Option A, 5, 2 and 5, 3. Option B, 5, 3 and 3, 5. Option C, 2, 3, and 3, 5. Option D, 2, 5, and 5, 2. Question number 8. The ages of Paul and Peter differ by 6, and the product of their ages is 187. If x is greater than y, write their ages in the form x, y. We have option A, B, C, and D. Question number 9. Which of the following is a factor of 15 plus 7s minus 2s squared? A, s minus 3, B, s plus 3, C, s minus 5, and D, s plus 5. Question number 10. What values of n would make the following quadratic function a perfect square? S squared plus 2 into m plus 1s plus m plus 3. Option A, minus 1, 1, B, minus 1, 2, C, 1 minus 2, and D, 2 and minus 2. Question number 11. If alpha, beta are the roots of the equation 3s squared minus 5s plus 6 equal to 0, find the values of alpha over beta plus beta over alpha. A, 11 over 9, B, 11 over 18, C, minus 11 over 18, D, minus 11 all over 9. Question number 12. Solve the equation 3s minus 2 into 5s minus 4 equal to 3s minus 2 all squared. A, minus 2 over 3, 1, B, 1, C, 2 over 3, 1, D, 2 over 3, 4 over 5. Answers. Number 1, D, 2, B, 3C, 4A, 5A, 6C, 7D, 8C, 9C, 10C, 11C, and 12B. Here is the nugget for today. Learning is a treasure that will follow its owner everywhere. It never exhausts the mind.